So let's go ahead and start. First thing I want to do is I want to look at our unknown 4 liquids here, and then we're going to identify with metals first to see, let them dissolve a little bit or not. Are they dissolving or not? So let's go ahead and switch. All right, so here is our chemical puzzle that I've set up. I've put it on a wood tray because, you know, this gets a little messy. Acids and bases, as I said, acids can react with metals. I don't want to really leave it out on a table and have it touch anything. So as we do this, I am going to write my notes down here, whether we see it react with metal, whether we see it conduct electricity, and then in the very end decide what do we think all 4 of these unknown liquids are, and then we'll check the litmus on them, and then last we'll check with the pH paper. So let's go ahead and get started. I'm going to go ahead and put the metal into these 4 liquids first. So I'm going to start with just, this is magnesium, throw it in there. Throw magnesium in this one. You seeing anything? Throw magnesium in this one. I'm not really seeing a lot yet, but there's a reason, is I'm gonna let it sit for a while and I'm gonna do this first. Ooh, that one went crazy. Let's do that note right there. So this last one, we should be writing that high bubble reaction with metal. Okay, so we're guessing that one has to be an acid, and I'm guessing strong, because look at that thing go crazy. Whoa, just look at it. Really bubbling, a lot of even gas formation coming off. I don't know if you see that or not. Okay, and it's actually, don't want to smell that. Woo, it's pretty dangerous. Okay, anything else? Let's see, do I see anything? Whew, that stuff is smelly. I'll have to, I'm just gonna leave them for a little bit. Okay, the next thing was the conductivity tester. So let's go ahead and move on with that. I know there's 1 strong acid, 1 strong base, 1 weak acid, 1 weak base. So one of these metals has to be reacting, but I don't know which right now. And because of all that gas, I'm just gonna switch because it stinks. So let's go ahead and take this and try to see what we think this one is. Okay, it's lighting, but we need to compare. So let me get a probe and, sorry guys, I'm gonna rinse it off a little bit in between so it don't have any contamination. Can you open that door too, Logan? Or okay, so we checked that. You saw how much the light bulb lit with it. It definitely lit, right? Then we're gonna go here. That one lights too, but we can't really compare. So these both look like they were lighting the same amount, right? Okay, so now let's see whether or not the next 2 light, but then also how much. And what you see me doing is I'm just rinsing the conductivity tester so they don't mess up. Okay. So that one is also really, really bright. And also with this one, you see the green lighting. The other one, I don't think the green was lighting. Let me show you that difference. I apologize for you having to look at my messy camera recording here. But let me show you this one more time. Do you see how that green light, maybe it's harder to see in the camera, but it's not as strong. Okay, and then obviously let's go in here. Oop, I can't fit. That's not good. I'm gonna have to set this down for a second here. See if I can get it that way. Oh, hold on. We know this is definitely something because look at that thing. It's just going crazy. Sort of scared to touch it here. Okay. And getting this recording is really hard to do. Okay, hold on, you guys can't see that. Trying to get it so you can actually see it. And then let me move the liquid to it. Okay, you can see that that is super bright and both of them are bright. Okay, so strong, bubbly, not so bubbly on any of these. Let's just take a look and see if we see any sort of bubbles at all. Let me just... get that in view. I don't know. I'm going to try a different metal. So I'm going to put some magnesium in. Oh, you know what? The magnesium went right away. There we go. So we do have a positive with the metal on that one. But it was not as crazy as that one. And honestly, guys, I don't even want to put the magnesium in there because it's going to create too much gas. That's really toxic for me to smell. So that one, bubbles. With Mg metal, but not zinc. That was the first metal I put in. So it's reacting with one of the metals, but not the other. This one is highly reactive with the zinc metal. Lots and lots of high bubbling. So we could tell that that one is some sort of an acid because of that. Why not? I'll just, you know what I'll do is I'll cut this. Let me cut it down so it's super small. Hold on. You ready? I've got a super small magnesium. And I don't really want to do anymore because it's giving me a headache already. So I'm going to put this teeny tiny little one in. Ready, set. Whoa, bam. Did you see not only as soon as it hit, it also broke apart into like, that was even worse. This one's still sort of slowly going, but you see the difference? That one just massacred it. So this one, we can go ahead and say we have violent bubble and broke apart the magnesium metal for this one. So these two are like weak, strong for sure based on the reactions, right? So weak, and then strong is our guess so far, right? And so we are saying that this one is basically, we think it's an acid for that reason. So we're gonna label that acid, weak, that's what we think it is. And we think this one is a strong acid. Okay. Let's see, what else can we do now? We know that neither of these have reacted at all with the metals. No need to even throw anything less in. It's like that one's still going. We know there's only two bases. One is strong, one's weak. So what do we need to do? We need to figure out which one of these is strong or weak based on the light. So that one's a little tough because I got to try to let you guys see this with the light. And the light is not very distinct. So let me try one more time to do this. I'm gonna go. Okay, so that one, the light is super bright, right? I don't know. This one's actually weaker and I can see it with my eyes, but I feel like the camera just picks up on all the shininess. So I'm trying to get it in a way that maybe you can see a little less. That one's just not as intense. It's hard to really see that on camera, but it's a little bit fainter. Okay, so we've got, I think anyways, the left one is weak and the right one is stronger. And so I'm gonna say no reaction with metal. I forgot to write that. No reaction with metals. No reactions with metals. That's gonna indicate that we're dealing with bases here because they don't react with any of the metals. And then this one just had a fainter light and a brighter light, which means higher conductivity. And again, it's sort of the light bulb's shininess is a little hard to decipher in the video, but hopefully you saw it. And this is lower conductivity because they both conduct, but conductivity. Trying to spell. So that means I think this one is the weak base. I think this one is the strong base. So let's see how we did. All right, the next thing is litmus paper. So red litmus paper turns blue in the presence of a base. So I'm just gonna go ahead and test those real quick. Let me get some papers out here. Let's do the red first. So we've got red. We expect this not to do anything, right? And it didn't. So acids don't make red litmus paper change, okay? So nothing on that one. This one, ooh, turned blue. Exactly what we thought, right? So let's add those notes. So we're gonna put red litmus turned blue. And this one was red litmus, no change. Okay, this one, let's see what it does. Red litmus turned blue for sure. So we know that one's a base. Red litmus turned blue. And then let's see this one. We don't expect anything. Nope. So red litmus, no change. All right, next we do the blue litmus. Okay, so now we're gonna do blue litmus. So blue litmus will turn red in the presence of an acid, which we think this first one is a weak acid, so let's see. Yes, it turned it red. Next one, this one we think is a base, we think no change, nothing. Okay, let's write that stuff up, by the way. So this one, blue litmus, turned red. Blue litmus, no change. Okay, let's do these. Base, do we expect bases to turn blue litmus? Anything? No, and it didn't, just like what we thought. Blue litmus, no change. And then last one, acid, do we expect, oh wait a minute, the blue litmus should have turned red. Wait, what am I doing? No, blue litmus, sorry, it's the acid, sorry, I'm having one of those moments. Okay, blue, red, yes, we saw that. That one worked, blue turned red, just like we expected. I was right, sorry guys. One of those moments, what am I doing? Trying to record and do this all at the same time is crazy. Okay, blue litmus turned red. So we just got our second validation that yes, we're doing this right. This is an acid, that is an acid because the blue litmus turned red for both. The red litmus turned blue for both of these, which indicate that we're doing it right. The last thing we want to do is just sort of add pH paper to test how strong, how weak, and then do some indicator change. All right, so the last step is to verify how we did and then how strong or weak we're talking here. So this is a universal indicator. It will change color and indicate a range of pH, and then we're gonna really check it with pH paper last. So I'm just gonna add the universal indicator real quick, some drops in, and see what color it changes. Ooh, nice pretty red. This one is a purple looking. This one's like a darker purple, is what I'd say. And then that one's like hot pink. That one's sort of like orangey pink, I would say. All right, now let's check. Hold on. Okay, so I added the indicator. And this one is, we would think it would be the purple. We thought this one was the strong base, and we thought this one was the weak base. But I'm not seeing that. I'm actually seeing swapped pHs, which is really weird. So I'm not actually sure what's going on with this, but our pH paper will tell us what it is, because I would have expected this to be swapped. I would expect the purple to be the pH that's 10, and then so we may have either chemicals are going bad, or I don't know. I'm going to use the pH paper net because that's all I can do. The strongest pink is the most acidic. That one's lining up. So let's do one more thing here, and that's why I always bring lots of tools in my tool belt to make sure we're getting the right answer. So let's do pH paper now. So we're going to use the pH paper now because I feel like there was just, and I'm not even going to touch that strong acid. So I'm just going to put it in like that, dip it in. Match the color, that's like a 1. That is a super strong acid. So pH 1. And it looks like hot pink with universal indicator. Right? Let's try this base. I'm not going to use my fingers, I'm going to use the tongs. This is the one I'm curious what is going on. This one, yeah, see, I feel like maybe the indicator is off or something, because you can see it's like a 14. It's not green, it's definitely blue. Get some light on there. You guys can see that's blue, and so it's more of a 14. So I don't know. So for this one, we had pH was 14, which is a very strong base. But it looked like, actually it started, indicator started purple. We'll have to rewind the video. And then it changed into like a green, and I don't know why it did that. Maybe it's because I added the metal and that's doing something, I don't know. And then here, this is a weak base. So let's see what color. See how that's like a lighter? I don't know if you can see that. It's a little bit fainter, like the lighter purple in the middle there. So that's probably a 13. You know, it's pretty strong though still. So I would say it's like pH 13. I think I might have just grabbed the chemical that maybe wasn't super. So pH was about 13. We might just call that one strong as well. I thought I'll tell you about it in a second. Just hold on one second. So that one was pH 13 and the color was purple indicator. And then last here, let's see this weak acid. Have like a lighter colored, oops, probably like a 2 to 3. I'll just put 3. So pH 3. And we have a light red indicator. Okay, so we did all the tests, and now let's see what we're dealing with here. Okay, strong stuff on the right. This was 6 molar hydrochloric acid. Strong acid, yes. Super strong. 6 molar, and the M stands for the high concentration. So that means there's a lot of hydrochloric acid. This stuff is really dangerous. The next one we have sodium hydroxide, very strong base. So this was also 6 molar. Let me move that over. Which means high concentration. Strong base. Oops, I don't want to put strong base. I want to put NaOH, which is sodium hydroxide. And then this one is household ammonium, like your Windex, which is NH4OH. So ammonium hydroxide, and it is, where's the molarity? It's just household. That's why I was like, this household Windex sort of stuff should not have given, and I don't know, should have just been that. So this one is NH4 ammonium ion hydroxide, and then it's just like household Windex sort of thing. Ammonium. And so it's ammonium hydroxide. It maybe is not, what I was thinking is that this might have been sitting around a long time and some of the water left and made it a little stronger. That's the only thing I could think maybe has happened. But we always have errors come up. This one's just vinegar. Vinegar, which is acetic acid. And that is CH3COOH. Just a weak, vinegar weak. Okay. And there you have it, guys. I think we did a decent job of all of our stuff online. I hope you now understand the difference between not only an acid and a base, but a strong acid and a strong base. And there you go. Just saying goodbye, and I will see you guys in class. All right. Bye.